Welcome back, dear students. So, today again I have come with my next episode on the chapter Refraction. Okay, if you follow my previous episodes, I already uploaded some of the episodes and I described over there the theoretical part, what is refraction, what is the rules of refraction, means how the ray will bend. Okay, when it is coming from rarer entering into denser medium, or coming from denser entering into a rarer medium. Okay, as well as I discussed about the laws of refraction. Okay, and what is critical angle, what is the total internal reflection. Okay, so these all things I discussed, and some natural phenomenon. Okay, so how it is happening. Okay, so everything I discussed. So you can go through my previous episodes, you can have the clear idea about this. Now, to get more video like this, subscribe my channel Physics Scholar, and you will be updated with all my videos, and hope it will be helpful for you for all the classes from classes 5 up to higher secondary level of any board. Okay, now let us start the numerical problems today. Okay, some of the numericals will do obviously. Okay, so some easy, some hard, mixed and match will do. So this is basically a very important question for the board exam also. Okay, so what I have told, suppose this is a sphere. This is a sphere. A ray of light passes. See, all of you, a ray of light passes. Okay, and when it is refracted, it is touched. This is the radius, two radius. These are the two radius of the sphere, and the angle between this radius is theta. It is given the angle between the two radius is theta. They are lying at an angle of theta with each other, and when the ray is refracted through the sphere, then it will touch the two end. Okay, two end of the two radius, and this is the path of refracted or emergent ray. Okay, so we have to determine the angle of deviation. So quickly, what is the angle of deviation? I am giving you the idea. So suppose it is air medium and it is suppose water. Okay, it is not related to math. What is the angle of deviation? I am giving the idea. Okay, so suppose the ray of light fall on the surface, common surface between the two medium, and this is the perpendicular drawn. So it is rarer medium and it is denser medium. Okay, so now it will move towards the perpendicular drawn. If this extra medium is not there, so this should be the path of light. So due to this medium, okay, it is what, deviated at an angle of what, delta. Okay, that means it is angle of incident I, it is angle of refraction R. So here I is equal to, okay, so now how we can find out delta? Delta is equal to what? I minus R. Okay, for this delta will be R minus I minus R, and suppose, so that is known as the angle of deviation. Means the angle of deviation of light due to the refraction is known as angle of deviation. Okay, suppose it is water medium. It is water medium and it is air medium. Why it is I minus R? Because here I is greater than R. Okay, now a ray of light falls on the common surface or incidents on the common surface. It is I, and it will move away from the perpendicular. Okay, so suppose it is R. Okay, so this should be the path. Okay, so due to this, okay, it is deviated at an angle. So this angle is what, delta. So what is delta? It is deviated by this angle. Okay, due to this medium actually. Okay, so what is angle of deviation? Delta is equal to what? R minus I. Okay, this angle and this angle will be equal. It will be I. Okay, so total delta is equal to what? R minus I. Okay, so here R will be greater than I. So this is how we can find out the angle of deviation. Okay, clear? So this concept we have to utilize in this sum. So see here, see, this is the original path. If no sphere is situated, if the light is coming through this path, then this will be the original path of light. As the sphere is situated, so this will be the emergent path of light. Okay, this is the emergent path of light, right? Now, due to so this is the angle of deviation. Okay, this is if we extended it, so this is the emergent path and this is the actual path of light. Okay, so this should be the angle of deviation. So it is derived as delta. Now see, all of you, this is a triangle TQR. So this one a triangle. This is a triangle. So it is the external angle of the triangle. So it is equal to the two internal angles of the triangle. Okay. So now what we can write? From triangle TQR. TQR is a triangle. So delta is equal to external angle. Okay. So what we can write? Delta is equal to summation of the two internal angles. Okay. So TQR, angle TQR plus angle what? TRQ. Okay. This will be the summation of these two. Okay. Now see, these two are OQ is equal to OR. Why? Because both are radius. Okay, radius of sphere. Okay, OQ and OR, both are the radius of the sphere. So that means what? Both are radius of the sphere. So these two angles will be equal. So this angle refraction will be R, and here the angle of incidence will also be R. So both angle, this angle OQR will be equal to angle ORQ. Okay. So as these two angles are equal, that's why the angle of emergent will also be I. Okay. Now what we can write? Angle TQR. This angle, what? It will be R minus, just I described. It will be what? I minus R, because from air medium it is coming to denser medium. So here this angle will be what? I minus R. Okay. And angle this one. Okay. So angle TRQ. Angle TRQ. So this angle will also be what? It is I and it is R. So it is also will be I minus R. Therefore, what we can write? Delta is equal to what? Summation of these two angles. So we can add these two. Okay. So I minus R plus I minus R. So 2 common, I minus R. Therefore, delta by 2 is equal to I minus R. Okay. Therefore, I is equal to delta by 2 plus R. Okay. So this is, you can give equation number 1. Okay. This is, you can give equation number 1. Clear? Now, what we can write? Ray of light passes through a theta refractive index of the material is equal to sin I by sin R. Okay. Mu is equal to sin I by sin R. Okay. Now, what we can write now? Again from triangle. See, this is the triangle QOR. So the summation of three angles of the triangle is what? 180 degree. Okay. So from triangle QOR, what we can write? R plus angle r plus angle theta is equal to 180 degree. Okay. So therefore twice r is equal to 180 degree minus theta. So therefore r is equal to 90 degree minus theta by 2. It is equation number 2. So what you can write? Mu is equal to sine. What is the value of I? Sine I means what? Delta by 2 plus r. Delta by 2 plus r divided by sine. What is the value of r? Okay, we will write it together. Theta by 2. Okay. So is equal to sine. What is the value of r now? Delta by 2 plus r means what? 90 minus theta by 2. And sine 90 minus theta by 2 means what? Cos theta by 2. See, we have found this cos theta by 2 already. It has come. So sine 90 degree minus half into what we can write? Theta minus delta. Okay. We are taking 90 degree at the beginning. We are doing half common. Minus half means what? Theta minus delta. Okay. Whole divided by cos theta by 2. Therefore, mu is equal to sine 90 minus theta means what? Cos theta. Cos of half into theta minus delta divided by cos theta by 2. This is proved. So, you have understood? Okay. So, this we have proved here. Okay. So, I am explaining once again. Look it carefully. So, this is a sphere. The refractive index of the sphere is mu. Clear? It is there. Okay. A ray of light incidents on the sphere and refracted through this path in such a way that it will touch the two ends of the two radius of the sphere, and the angle between the two radius of the sphere is theta. Okay. Now we have to find out, this is the angle of deviation. We have to find out the angle of deviation, okay, between the incident ray and the emergent ray. So angle of deviation is here is theta. Now from this triangle we are finding the external angle delta is equal to what? Summation of the two internal angles. Delta is equal to summation of the two internal angles, means angle this and angle this. So delta is equal to TQR plus TRQ. Okay. So that is the value of delta. Now as the two radius are equal for the sphere, that's why these two angles will equal. That means this is the refracted angle and this will be the incident angle of incident. And this will be the angle of incidence here, this will be the emergent ray, and this will be the angle of refraction. Now, what we can write? The both, this is R, this angle will be R, this angle R, and this will be I, and this will be also I. So, for this point, angle of deviation will be what? Angle of deviation will be I minus R. For this point also, angle of deviation will be I minus R. So, delta is equal to what? Summation of the two angles. So we are adding these two angles. So it is coming 2 into I minus R. Now taking 2 at this side, so delta by 2 is equal to I minus R. So I is equal to what? Delta by 2 plus R. Clear? Now what do we know? Mu is equal to sine by Snell's law. From Snell's law we can write it from Snell's law. Okay. What we can do? Mu is equal to sine I by sine R. Now again from this triangle, the summation of the three angles is 180. Very easy. Okay. So twice r is equal to 180. Okay. Minus theta. We are shifting theta over there. So dividing all the terms by 2. So r is equal to 90 degree. 180 by 2 means 90. Minus theta by 2. Now mu is equal to what? Sin I by sin r. So putting the value of I. Okay. Putting the sin means what? Sin I means what? Sin I means delta by 2 plus r. Okay. The value of I. So this is the value of I. Okay, I means delta by 2 plus r. We are putting this value. And sin 90 minus theta by 2. Sin r means what? R means what? 90 minus theta by 2. That is the value of r. So sin delta by 2 plus value of r is what? 90 minus theta by 2. And sin 90 minus theta means what? Cos theta by 2. Okay. And here we are writing 90 at the beginning. Minus half common, then theta minus delta. So mu is equal to cos sin 90 minus this full part is now theta. So that will be cos this part. Okay, divided by cos theta by 2. So this is your answer. So hope you have understand this. So let us move to the next topic. Okay. So after that numeric sums, we will do many sums, many problem we will solve. So before moving to the next numericals, okay, we are determining, suppose the actually apparent displacement. Okay, so apparent displacement means the if we are watching from here, okay, we see the P point shifted upward at this point at position Q. Okay, and we have to determine the value of PQ, means what will be the shift, okay, or apparent displacement. Actually the P point is here, but from the outside of the medium, if we are watching it from the rarer medium, then we see the point P at this position, point Q. Clear? Now, how to determine how much displacement will be there? Okay. Now see, I am explaining these diagrams. Okay. So suppose inside the medium, okay, denser medium, the point P is there. So one ray will move straight. Okay, without any refraction, it will without changing any direction, it will move straight. Another ray at a point, another ray PC will incident at point C, and from denser to rarer medium, it will move away from the perpendicular. So that means what? The angle of incidence is I, angle of refraction is R. Okay, and these two lines are parallel. These two lines are parallel to each other. Okay, so suppose the refractive index of the rarer medium is mu1 with respect to this, and the denser medium is mu2 with respect to this. Okay, now what you can write? So I already explained the diagrams. Okay, now what you can write for these points? So refractive index of rarer medium with respect to denser medium is mu1, and refractive index of denser medium with respect to rarer medium is mu2. So what we can write from Snell's law? We can write what? Mu2 sin I is equal to mu1 sin R. Therefore, mu2 by mu1 is equal to sin R by sin I. Okay, mu2 by mu1 is equal to sin R by sin I is equal to, what is the angle of sin R? Sin R means NCD. This is the angle of R. So sin angle NCD divided by R means what? Sin. I means what? I means this one. Okay. So PCN1. Angle PCN1. Okay. Now as NN1 and this line PB are parallel. So from the diagram, what you can write? These two lines are parallel. This angle will be equal to this angle, and this angle will be equal to this angle. Okay. So angle what? I means PCN1 is equal to angle. This angle will be equal to this. So CPQ. CPA you can write. Okay. Same CPA is equal to I. Okay. And angle R. R means what? This is NPA D NCD is equal to angle CQA. CQA is equal to R. So instead of this angle, we can write now this. So what we can write? So mu 2 by mu 1 is equal to sine NCD. Instead of NCD, what you can write? CQA and sine PCN 1. Instead of that, we can write PCN1 CPA. Okay. So instead of this, we can write this. Okay. Now, so Q1 by Q2, this will be reversed. Sine angle CPA divided by sine angle CQA. So sine CPA means what? Sine CPA, this angle. So perpendicular by hypotenuse. So perpendicular means what? AC by hypotenuse means what? QC divided by sine CQA. Sine CPA. Sine CPA. Perpendicular AC by hypotenuse CP. It will be CP. And here sine CQA. That means perpendicular is AC by hypotenuse is CQ. So AC will be cancelled. Therefore CQ by CP. Okay. CQ by CP. Okay. Now if the refracted ray, we are assuming that it is very close to each other. That means this angle is not too much. If angle I is very small, then what we can write? Then we can write CQ. That means what? A and C will be very close to each other. Then we can write what? CQ is equal to AQ. Then we can write CQ is equal to AQ and CP is equal to AP. Then we can write what? Mu 1 by mu 2 is equal to CQ means what? AQ by AP. AQ by AP. Okay. So suppose AQ by AP. Okay. Suppose now this medium mu 1 is air. So if rarer medium is air or vacuum, then mu 1 will be what? 1. Okay. And let mu 2 is equal to mu. So what you can write? 1 by mu is equal to AQ by AP. AQ by AP. Okay. It is known as AQ by AQ. Okay. Is equal to AQ means 1 by mu is equal to AQ by AP. Okay. So let depth is equal to D. Okay. Let depth is equal to D is equal to AP. Okay. Therefore 1 by mu is equal to AQ by D. Therefore AQ is equal to D by mu. AQ is equal to D by mu. Okay. AQ is equal to D by mu. Clear? Mu. Right. So PQ means what? PQ means apparent displacement. So this is the portion which is shifted. Displacement is equal to what? Total AP minus AQ. What is the total length AP? D minus D by mu. So if D common, then 1 minus 1 by mu. Okay. So this is the actual, so apparent shift or displacement. Displacement is equal to what? D into 1 minus 1 by mu. Okay. So this is a very important formula and also very important for doing sum, and also derivation of this formula is very important for the exams. Okay. So this is, I think you have understood. Okay. So if it is water, so the refractive index of water with respect to air is 4 by 3. Okay. So what will be the, suppose it is water and you are watching from air medium. So what will be the displacement in case of water? Okay. It is what? Mu is equal to 4 by 3. So displacement will be what? D into 1 minus 3 by 4. So D into 4 minus 3 is equal to D by 4. So in case of the water, the object will shift, okay, 1 by 4th of the total length. Okay, suppose the total length is 40 meter, then the object will shift 10 meter above. Okay, 40 into 1 by 4 means what? 10 meter above. Okay, so these proofs also very important for the exam. Prove that in case of the water, okay, if the object is inside the water, if you see it from the air medium, then the apparent shift of the object is 1/4 of the total depth of water. Okay, from the surface up to that particular point. Okay, so this is also very important. So hope you have understood this, and to get this type of very interesting and very easy. Okay, after watching this, I think it will be very easy for you to solve. Okay, so to continue watching this, you have to subscribe my channel, and I am coming back very shortly after with some more numeric problems. Okay, thank you.